Hello everyone, welcome to this lecture video tutorial in the mathematics of the modern world. Enjoy learning.
The atomic bomb.
Hello everyone, in this lecture video we will be discussing chapter 5, as you can see here, in the mathematics of the modern world, entitled Apportionment and Voting. So we are now in the part 3, as you can see here, uh, here part 3, weighted voting system. So in this lecture, the student are expected to first is to understand, okay, the definition of the weighted voting system. The second is to introduce the type of voting system, weighted voting system. Okay, as you can see here, we have type. There are 4 types, just like the apportionment and the voting topic, part 1 and part 2. Okay, and then we are going to determine also what do we mean by the winning coalition and the critical voters in a voting system. And then finally we will discuss the power of a voter in a voting system, this one here. This talks about the Banza power index. Okay, so for our first definition, as you can see here, let's define what do we mean by weighted voting system. So for our first definition here, let's say this one, a weighted voting system, as you can see here, is one in which some voters have more weight on the outcome of an election. So what does this mean, this definition here? Okay, there are type of voting system which is different from in our topic in part 2, where in that scenario we consider the preference schedule. Okay, but here in this topic, uh, the weighted voting system, in this scenario, the voter, okay, has a weight. Okay, so meaning to say, if you have a voter V1, that's denoted by V1 or A. Okay, voter A or voter V1, voter V2 for voter B, which is similar to that one, that kind of scenario. Okay, so just imagine this situation. Let's say here, if you have voter V1 or voter V2 or voter V sub 3 and so on and so forth, up to voter Vn, you can associate this as a voter A or voter B or voter C and so on and so forth. Okay, so just imagine that way. In this kind of voting system where the voter has a weight, a voter V1 has a weight. For example, we have you give a weight for this particular voter, let's say 3. Okay, and a weight is a number, a whole number. Okay, another for this voter, the weight is for example, the weight for this one is 10. Okay, what does that mean? Meaning to say that his votes weights 3. Okay, represents 3 votes. It's just like as a single person has 3 votes on his own. This person here, voter V2, has weights which is equal to 10, This means that his votes represents 10 votes, okay, and so on and so forth. Okay, why is that? In this example here, let's try this color here, this example here, uh, for example this one, okay, stockholders of a company, okay, which is very familiar to us. I don't know if you are familiar with electoral college, which is this can be found in the United States, United Nations Security Council. I don't know if you are familiar with this one, and also this what you call European Union. So let's try to explain this stockholders. For example, if you have a company, uh, there's not if you have a company there. If what if there is a company, so where example Jollibee company, where you can buy a stocks, okay, so that company has many owners, okay, the owners of that company is what we call the stockholders, okay, this one here. So for example, if you buy 100 shares or stocks, okay, then if uh, the company decides to, for example, this one, he wants to, let's try to write it this way, they plan to uh, let's say another menu, fried chicken, uh, chicken menu, okay, menu in which this menu here is not the usual way, okay, not the usual menu. This is because this chicken is fried in the example in is fried in the volcano. Maybe it's just a joke. uh, then what if the stockholders here, for example, there are 100 stockholder, okay, stockholders, okay, 100 stockholders, okay, holders, that one, okay. So for the first stockholder, example V1, he has a share which is 3 shares, okay. So example, for every shares we have 20 pesos, or for every shares we have 100 pesos, that one, that way, okay. So for example, this V1 here, voter stockholder V1 or stockholder A, he has 3 shares. Stockholder V2 or letter B, he has 10 shares, and so V3, this one here, he has let's say 20 shares, okay, and so on and so forth, okay, and so on and so forth, okay. Remember, there are 100 stockholders. If they want to pass a measure, okay, if they want to pass this menu here as the new menu for the Jollibee Corporation, they have to vote, okay. All the 100 stockholders must vote, okay. So meaning to say, example, if you have this one here, let's say, let's try to introduce this voter D, let's say this is B4, okay. And what if we have here 20, 10, 30, 33? So what is 33 minus 100? Let's say 100 minus 33. So we have, what if he has 67 shares? And we reduce this, let's try to reduce this stockholders to 4. Okay, let's try to replace that by 4. Only 4 stockholders, meaning the owner of the Jollibee Corporation. Jollibee, is this the spelling of Jollibee? Corporation is let's say there are 4 stockholders, okay. So this means that this voter A, B, C, and D are the owners of this corporation, and they want to try another menu, which is what we call this fried chicken menu, where it was cooked in the volcano. They want to introduce this menu. Okay, so meaning to say, it says here that this voter here, this stockholder here has 3 shares. Second, B here, stockholder has 10 shares. C here has 20 shares, but D here has 67 shares. Okay, so if they want to vote, notice that when the voter, the stockholder D, uh, raise his hand, then automatically the fried chicken menu will be passed as a new menu. Eh, this menu here will be introduced as a new menu. Why? Because as you can notice, his vote, this one here, his vote, which has equivalent to 67 votes, will outweigh all these votes here. Okay, since if for example, if you want to pass a measure, meaning if the quota is by the way, the letter Q here, this definition, this one here, this definition, the number of votes that are required to pass a measure is what we call the quota. The quota is calculated usually by dividing the number of shares, or the number of votes divided by 2 plus 1. Okay, so the quota here, the formula for the quota is number of votes, number of voters, no, number of vote, not votes, number of voters usually divided by 2 plus 1. Okay, so this is the formula of the quota. Okay, usually, but if there is a given where the quota is already written, then you cannot change that one. But if the quota is missing, then the formula for the quota is this one here. Okay, number of voters divided by no, really not the number of voters, this is the number of weights, number of voters weights, sorry, voters weights divided by 2. Example, this one, there are 100, this is equal to 100 weights. Okay, 100 weights. Okay, so 100 divided by 2 for this one here, 100 divided by 2 is 50 plus 1, we have 51. Okay, that one. Okay, this is the quota. So meaning to say, even if the stockholder ABC will not vote, and D will vote for this new menu, it will be pass. Okay, it can pass because as you can see, the required quota is 51, but this voter D here has 67 votes. Okay, if this voter here D is absent, then the measure cannot be passed. Okay, why? Because we have 20 plus 10 plus 3 is 33, and 33 is not what they call this one, is not greater than the quota. Okay, so that's what we mean by the weighted voting system. So I hope now that you are familiar with this. I am going to give more example or illustration that later. Okay, so that's what we mean by this example here is stockholders of a company. So for this one, electoral college and so on and so forth, you can search that one in the internet. Okay, for our fourth definition, says here, the weight of a voter is the number of votes controlled by the voter. Okay, so for example, this voter B1 here, his weight is 3, and it was controlled by this voter here, V1. Okay, this voter D here, which is denoted by V4, or other notation for voter D or stockholder D is B4. It has a weight which is 67, and it is controlled by this voter here, B4. Okay, that's what we mean by a weight. It is a number. It's not a fraction, it's not a decimal, it is a whole number. Okay, so for our fifth, let's say fifth definition, we have here fifth definition, a weighted voting system of n voters is denoted by this one. Okay, let me try to explain this by using this example here, the fried chicken menu for the Jollibee Corporation. So as I've said, the queue here, this one here, the queue here is what we call the quota. And usually, if it is not in the given, then the calculation for the quota is the number of voters' weights. Okay, you have the total. Okay, total number. So let's me write it, correct it one. Total number of voters' weights. Okay, divided by 2 plus 1. Okay, that's what we mean by a quota. So this W1 here is the weight of voter V1. Okay, remember that one. Okay, so this one here is the, let's try to write, this is weight of voter. Okay, voter V sub 1. Okay, this one here is the weight of voter V sub 2. Okay, so it is if the given is in this way, automatically the first component here is what we call the weight for the voter V1. The second here is the weight for voter W sub 2 here is the weight for the voter V2. Okay, W sub 3 here is the weight of the voter V sub 3, until you have the W sub n, which is the weight of the voter V sub n. Okay, this is the first voter, second voter, third. It was arranged already. Sometimes in the book, they will use ABCD. Okay, so other books, they will use this one as voter A, and this one here voter B or voter C. It doesn't matter. So whatever comes first here, second, third, and so on. So the first value here is for voter V1. The second here is voter V2, and so on and so forth. Don't be confused. Okay, and the Q here is what we call the quota. Okay, so in here, if we want to write this as a weighted voting system, this for this notation here, this is the general notation. Okay, if we want to write that one, you can write it as this way. Okay, try this in color. So our Q is 51. Okay, and then the first voter is A, which is 3, has 3 votes, 3 weights, and we have here 10, and then 20, and then finally we have 67. Okay, so this is for A, for B, and C and so on, C, D, and so on. Okay, so this is the usual notation for the weighted voting system. Please don't forget this notation. This is we will be encountering this notation more in the succeeding discussion. Okay, so now let me have another illustration. So to what do you call this one, to illustrate more the definition that we've discussed previously. Okay, previously discussed. Okay, so let me write it down, or maybe let me think first for another example. Okay, okay, for this illustration, one more illustration. This one here. Okay, let's consider. Okay, consider the Mang Inasal. Okay, Mang Inasal company. Okay, company with a total of let's say 200 shares. Okay, 200 shares of stock, and let's say we have three, okay, three stockholders, okay, stockholders, okay. Let's say the stockholders are denoted as A, B, and C, okay. So this stockholder now is this stockholder here, we will denote this one as V1, okay, the voter V1. Okay, this one is the voter V2, and this one also is the voter Visa 3. Okay, so 200 shares of stock, and 3 stockholders. So for example, okay, let's say this one color here. Okay, for example, if we have A here has let's say 90 shares, okay, has 90 shares. B here has also 90 shares, okay. Then C here, stockholder C has let's say 20 shares, okay, 20 shares, okay. So these shares here, okay, 90, these 90 shares, okay, means that A has 90 votes, okay. This stockholder A here has 90 votes. The same is true for B. The interpretation of 90 shares is 90 votes for B, and 20 shares means 20 votes for stockholder C, okay. So notice that RQ here, this one, if you total all the shares, this is 200, okay, 200, no, sorry, not that one, 200. So this implies that our Q here is the total number of weights, okay, weights. This one is can be considered as weights, okay, or shares divided by divided by 2 plus 1, okay. So this means this is 200 divided by 2 plus 1, okay. This is the usual, so the answer is 101, okay. So that's our Q, okay. So this implies that our weighted voting system is given by this one Q. We have 90, 90, and 20, okay. So this is for A, this is for B, and this is for C, okay. Do not rearrange that one, okay. So what does this mean, okay? This means that let's have an illustration here. If a vote, okay, vote of 51, no, not of 101, this one here, one or greater is required, okay, is required to approve any measure before the owners, okay, then a measure cannot be passed without two of the three owners. Okay, uh, voting for the measure. Why? So this measure here means that, for example, in the Mang Inasal company, they want amino to be add in their company. Okay, like just like fried chicken. Okay, where it was cooked in the, let's say, in a volcano again. Okay, so they want to pass that kind of menu. Okay, so it cannot be passed without two of the three owners. The owner is A, B, and C. Okay, three owners. Okay, for voting the said menu. Why? For example, if only A will vote and B and C are absent, then what will happen? Okay, what will happen if B and C is absent? So the required vote is must be greater than or equal to the quota, which is 100. So the votes is 90 because B and C are absent, so it cannot pass. Okay, so if two are present in the voting, then it can pass a measure. Example, A, B are present, then 90 plus 90, which is 180, which is greater than 101. Or if B is absent, A and C are present, we have 90 plus 20, which is 110, which is greater than also than 101. Okay, so it must be that in this kind of voting system, two must be present. Okay, if two are absent, then we can this kind of voting system cannot pass any measure. Okay, so meaning to say, although C has only 20 shares, C has the same voting powers as A and B. Okay, so imagine 20 shares, this one is 90 shares. If he is if he is absent, B and C are absent, then we cannot pass any measure. Okay, it must be what do you call this one, two of the three owners must be present in this scenario. Okay, so that's what we mean by a weighted voting system. Okay, so the power of C is the same as of that A and B. Okay, so let's try to modify the okay, the this weighted voting system here. Okay, let's try this color here, maybe this one. So let's try to modify the weighted voting system above. Okay, so let's try this what they call this one, voting system. Let's modify the same company, Mang Inasal, but now a new stockholder was added. Okay, it's added to the company. Okay, so let's try this. We have the same shares, 200 shares. So you have 101. The quota is 101. So let's try this one. 54 shares, 52 shares, and 50 shares, and the other is 44 shares. Okay, so for this, this is our voter A, this one is voter B, voter C, and or stockholder C and stockholder D. Okay, you can denote this as V1, V2, V3, and V4. Okay, so a new stockholder is added. Okay, so what does this mean? Is the value here 101. So remember, if you add this all, 54 plus 52 plus 50 plus 44, this is 200. So 200 divided by 2 is 100, plus 1 we have 101. Okay, the same quota as this weighted voting system. So what is the conclusion here? So let's try this color. Note, in this case, that any two of A, B, both owner A, B, and or C can pass, okay, pass a measure, okay, but as you can see here, but the paired with any of the other stockholders cannot pass a measure. Okay, so why is that? Any of the two, as you can see here, any of the two stockholders, okay, so we have 54 plus 52, which is 106, which is greater than 101. 54 plus 54 plus 52, which is greater than 101, or 54 times plus 50 is 104, which is greater than 101, or 52 times plus 50, which is 102, which is greater than 101. So any of the two voters, A, B, and C, it can pass a measure. So meaning to say, the fried chicken is will become a new menu. Okay, so in this scenario, however, if D is paired to any, okay, any of the previous stockholder, okay, A, B, and C, it's called A and D, or B and C, or C and D. If you pair them, then notice that it cannot pass a measure. So we have 54 plus 44, it's short, 98, which is not greater than 101, or 52 plus 44, or 50 plus 44, which is not greater than 101. Okay, so if you paired D with any of these stockholders, A, B, and C. So what does this mean? So this means that unlike in the previous scenario, that voter A and B and C have equal powers, okay, in D, in this scenario, D has virtually no power, okay, no power, even though D has only how many 6 shares, okay, has only 6 shares less than the owner C. Okay, so it says here that this implies in this scenario here, this one, C has the same voting power as stockholder A and B. Okay, so I hope now that you are familiar with this scenario. You are now able to understand the first what do you call this one, the first objective. Okay, understand the definition of the weighted voting system. Okay, so this is what do we mean by a weighted voting system, and there are so many examples here uh, in this topic that is not limited only to stockholders. Okay, there are many more. So just imagine. Okay, we have electoral college or United Nations Security Council or the European Union and many others. Okay, so let's try now to discuss the second definition, the types of the voting system. Okay, we are now ready to discuss the types of voting system. Okay, the first one is what we call the one vote system. Okay, system. Okay, so for this type of voting system, let me have this example. When you say one person one vote system, each in the system, each person has one vote. Okay, the weights are equal. Okay, so for example, this type of voting system, we have 6 1 1 1 1 1 2 3 4 5 6. Okay, so this example is what we call the one person one vote system. Okay, each person or each voter, let's have this voter here, v1, here v2, v3, v4, and then v5, and then v6. Okay, this is, or you can name it as ABCD. Okay, they are just the same, ABCDEF. Okay, so each voter has one vote. Okay, the weight of this voter W1 is 1. For W2 we have 2, and so on and so forth. Okay, so in here it says that each person or voter has one vote. Okay, one vote. Okay, and then in this voting system also, it says that a majority of the voters are required. Okay, note, let's say a note here. Okay, note, a majority of the voters are required okay, required to pass a measure. Okay, this means that if there is one voter that is absent, okay, then you cannot pass the measure. Okay, because the sum of the votes is equal to 5, which is less than the quota, which is 6. Okay, so that is one person one vote system. For the second type of weighted voting system, this is what we call the dictatorship system. Okay, so for example, in this for example here example, this one here. Okay, we have let's say 15, and then you have 16 here, and then 4 3 1. Okay, 2 4 4 3 2. Let's say this one. Okay, so in this type of voting system is what we call a dictatorship. Why? Because there is a voter here, voter V1, which is a dictator. Okay, meaning to say, if the what they call it, the company, okay, decides to pass a measure, this voter here can pass a measure without the other voters. Okay, without the voter B, C, and D, or the voter V2, V3, or V4. Okay, even if these three voters here are absent. Okay, so this is because as you can see here, if you sum the weights of the second, third, and fourth voter, we have 8, which is less than the quota. Okay, and also the other way of interpretation for this type of voting system is that if this voter is absent, then no matter what they do, what do these the remaining voters do, then it cannot pass a measure. Okay, this is what we call a a what they call this one, a dictatorship system, type of voting system. So in this system, the let's say this one, there is one voter. Okay, voter in which a dictator. Okay, there is one voter in which that voter is in which that voter is a dictator. Okay, dictator. Okay, so that's a dictatorship system. Okay, for the third one, this is what we call the null system. Okay, null system. Okay, this is this kind of what they call this one, weighted voting system is null if even all the voters are present, then the measure cannot be passed. Okay, so for example, this one, this example, we have 30 6 9 2 3 1. Okay, this kind of weighted voting system is a null system, because if you sum the weights of all the voters, 6 9 2 3 1, we have 15 21. 21 weights is less than the quota, which is 30. So this is what we call a null system. And if you ask, okay, just remember, if you ask why is it that the quota is the formula for the quota is equal to the total number of weights divided by 2 plus 1. So as you can see, you ask yourself that this is 10 is 15 21 divided by 2, so it is a fraction. Okay, so all you have to do is to round up. Let me recall that one. Okay, and plus 1 we have, which is not equal to 30. Okay, so as I've said, if the given is not already in this form, okay, then to get the quota is to sum the total number of weights divided by 2 plus 1. But if it is given in this way, then you cannot change this given. Okay, for example, this one it is given that the quota is 15, then you cannot change it to something like this one 20, 23, 24 divided by 2 is 12 plus 1 13. So you cannot change 15 to 13 because it is already in the given that the quota is 15. Okay, do not change anything if this was all this this notation for the voting system for number 3, for number 2, and for number 1 is already given. Do not change the quota. Okay, but if it is not given, the quota is computed that way. Okay, so what is this type of this system? This system is null system uh, if even all the voters are present, then it cannot pass a measure. Okay, so that's what we mean by a null system. Okay, for number 4, the last one, this is what we call the veto power system. Okay, so before I will define, I will write this example here first. Let's say if you have 20, the quota is 20, and then you have let's say not 20, let's say 21. Okay, so we have 7 6 5 4 3 then 2, this one here 1 2 3 4 5 6. Okay, there are 6 voters. The weight for the voter 1, W sub 1 is 7, W sub 2, or the weight of the voter 2 is 6, and so on and so forth. This this weighted voting system is a veto power system. Why? Because the sum of the votes, okay, the sum of the votes, as you can see here, we have 7 plus how much is this, 13 18 18 19 20 21 22 23, we have 11 18 22. What happened, I don't know how to add. 13 and 18 22 23 24 25 26 27. So let me change this to 27. I'm sorry. So this is 27. Okay, 27. Okay, this type of voting weighted voting system is a veto power because the sum of the weights is 27. Okay, which is the quota. Okay, and then if there is an absent, okay, if there is a voter here that will not vote, then we cannot pass a measure. Okay, that's what we mean by this veto power system. Okay, meaning to say each voter has a veto power. Okay, has a veto power. So as I've said, in this scenario, the total the sum of the weights is 27, and if there is an absent of the voters in this type of system, then one cannot pass a measure. Okay, and each voter here has a veto power. Okay, so let's define this kind of system. So if anyone, okay, anyone voter does not vote, okay, do vote for the measure, okay, it will fail, okay, it will fail. And one point also is that notice here that the sum of the weights is weights, or the sum or all votes, the sum of all votes is equal, okay, equal to the quota, okay, which is 27, okay. And also, second note here, each voter, okay, each voter is said to have, okay, said to have a, let's try this color here, veto power, okay. So that's what we mean by this type of system, okay. So I hope that you are familiar now with these four types of weighted voting system, okay. So for our next topic, we will be discussing on how to get the power of a given voter, okay. So we will be discussing the Banza power index, okay. So okay, we are now ready to discuss the Banza power index, okay. So let me give you a history here. It says here that the term Banza power index was reintroduced by John Banza in 1965. This is because this definition was originally created by Lionel Penrose in 1946, okay. The purpose of the Banza power index is this power index is a numerical way of looking at power in a weighted voting system. So just like I've said before in the discussion of the weighted voting system, I've said that the what they call this one, the voter has a power, okay, and that power is what we call the Banza power index, okay. And please take note that the Banza power index, the value of the Banza power index is between 0 and 1, okay. So it cannot be greater than 1, or it cannot be negative number. It is between 0 and 1. This is just like a probability, okay. So meaning to say, if it is closer to 1, then the Banza power, that voter is more powerful than the other voters. But if that voter is if the Banza power index is 0, then meaning to say that what they call this one, that voter is a dummy, okay. Let me I'm going to define that one later. These are the steps on how to calculate the Banza power index, okay. As you can see, there are 4 steps, okay. All you have to do is, first is you have to list all the winning coalitions. We will define that later here, okay. List all the winning coalitions, and then in each coalition identify the voters who are critical, okay. I'm going to discuss also what do we mean by critical. And the third step is to count up how many times each voter is critical, okay. And then last one is to convert these counts of fractions or decimals by dividing the number of times voter V is a critical voter by the number of times any voter is a critical voter, okay. So this is the formula, this one for number 4, the formula for the Banza power index. So anyway, before going to show you how to calculate the Banza power index, there is a definition here which is very important, like the meaning of the collisions. Okay, and what do we mean by a winning collision? Okay, so let's have a discussion here first. So what do we mean by collisions? It says here, it is a set of voters, each of whom votes the same way, either for or against a resolution. So meaning to say, this is just like a group. Okay, a group of people. It is a coalition, a group of people who are against a resolution, against to pass that resolution, or against to pass that measure. Okay, it is a group of voters in a certain weighted voting system. Okay, like for example in the stockholders example before. Okay, so maybe let's have an illustration here. I'm going to find an image, something here to about the collision. What do we mean by collision? Okay, so let's have an image here. I like this one, maybe this one here. Okay, this one, I like this one. Okay, that one. So let's put that one here. Okay, so for an illustration, okay, illustration, okay, so suppose that these people here are members, okay, are owner, okay, owner of let's say Jollibee, okay, Jollibee corporation. Okay, corporation. Okay, so for example there are let's say 100, suppose this is 100. Okay, 100 members. Okay, 100 members. Okay, and then these 100 members, it's like this situation just like before. Okay, they want this menu here, they want to pass a menu. Okay, they want a new menu. Okay, menu in this called fried chicken. Okay, fried, this is a spelling of fried. Okay, fried in volcano. Okay, that one, fried chicken fried in volcano. Okay, maybe this is correct because I write this one here. Okay, so suppose that this maybe 10 members. Okay, suppose we have 10 members here, 10 members. Okay, members are against, okay, against the said menu. Okay, against the said menu. So these 10 members here form a coalition because they are against, or they are not against, okay, the said menu, the said menu. Okay, and there are many other coalitions. Okay, there are many other coalitions that can be generated using 100 members. Okay, you can form 20 members in a given coalition, or maybe 30 members against the said coalition. It depends. Okay, so and maybe this person here belong to this coalition. Maybe she is not belong to another coalition, or maybe she is belong to another coalition again. Okay, so that's what we mean by a coalition. Okay, the winning coalition, as you can see here, is a set of voters the sum of whose votes is greater than or equal to the quota. Example, these 10 members here, if the sum of their weights, okay, of their votes is greater than or equal the quota, then this coalition here is a winning coalition. Of course, if it is losing, then the sum of the quota is less than. No, not the sum of the sum of their votes or their weights is less than the quota. That's what we mean by a losing coalition. It is opposite to the winning. The critical voter here is a voter who leaves a winning coalition and thereby turns into a losing coalition. So meaning to say, if these 10 members here, their coalition is a winning coalition, and then if that voter, example V10, V sub 10, okay, the voter 10 leaves the coalition, then this coalition now, if the sum of their weights or their votes is less than the quota, then that voter is what we call a critical voter. Okay, that's what we mean by a critical voter. Okay, I hope now that you are familiar with that one. The question is there it would be possible that there are more than one critical voter in a given coalition? The answer is yes, it could be. Just like the, what they call this one, just like the one vote, one person one vote system. Okay, that kind of weighted voting system is an example where all the voters are critical. Okay, in the one person one vote system. Okay, so it could be. Okay, so this one, dictator, I discussed this already. A voter has a weight that is greater than or equal to the quota. Okay, so just like my example before in the type of voting system, I discussed this that the dictator is a voter in which the weight is greater than or equal to the quota. Okay, the dummy voter is a voter who is never a critical voter and has no power. I discussed that already in the first discussion in I guess in the Jollibee Corporation, where there are three members of that company. I guess we have 90, 90, and 20. Okay, 90, the weight of the first voter is 90, the second voter is 90, and the third voter is 20. Or maybe I am wrong, maybe the second one. Okay, maybe the second one. I guess the dummy, or maybe not. I forgot. But anyway, the dummy is one that is never a critical voter. Okay, in which it has no power, meaning to say the Banza power index is 0. Okay, so that's what we mean by a dummy. I'm going to look that one, the one that I talked before about the previous example, if I am right or wrong. For now I am confused. But anyway, just like I've said in the formation of the coalition, okay, so that I've said that there are many coalition in a given weighted voting system. Okay, so it says here that this one, okay, this one here, let's have this color red. This one here, the number of possible coalitions of n voters is given by this formula, 2 to the n minus 1. So for example, we have here 100 members, so there are 100 voters. Okay, so the example, if you have your n here is the number of voters, so you have 2 to the 100 minus 1, that would be the number of possible coalitions. Remember, it's very large. That number is very large. If, for example, if you have let's say this kind of weighted voting system, let's say 7, 3, 4, and let's have 5 here. Okay, there are, the n here is 3. Okay, the n here is 3, and then I write that that the Q is 7. So you cannot change that. Okay, you cannot change the what do you call this one, you cannot change the quota. I write it already as 7. But if I didn't mention the quota, and all you have to do is to sum all these weights divided by 2 plus 1. Okay, so we have 9, 12, 12 divided by 2 is 6 plus 1, 7. Oh, it is correct. So maybe this is a coincidence. But anyway, so the number of collisions is collisions is equal to 2 to the 3 minus 1, which is equal to 2 to the 3 is 8 minus 1, also we have 7 collisions all in all. Okay, I'm going to teach you how to get these collisions, okay, by answering this example. Okay, let's now compute how to get the Banza power index of a given voter using these steps and these definitions here. Okay, so first is we are going to get the winning coalitions, not the losing coalition. Okay, the winning coalition. So let's read it first. The example says here the 4 staff members A, B, C, D. Okay, this is not always the case where you use A, B, C, D as for voter A, voter B, and C and D. Okay, but it is understood that the first that will come to the weighted voting system for W sub 1, W sub 2, it is understood that W sub 1 is A, or W sub 1 is the voter 1. Okay, you cannot mix it up. Okay, so please don't do that. Okay, of a college drama department use the weighted voting system. This one, 8. The quota is 8. Then we have 4 members, 5, 4, 3, 2. Let's say if the quota is really equal to 8 by using the formula, 5 plus 9 is 5 plus 4 is 9. Plus 9, 10, 11, 12, 13, 14. 14 divided by 2 is 7 plus 1 is 8. So this is correct. This is correct. The quota is correct. Okay, but again, don't forget, if the given is already a given, do not change. Okay, do not change it. To make casting decisions for a play they are producing, so they want to produce something. In this voting system, voter A has weight, okay, 5, B is 4, C is 3, D is 2. So we are going to compute the Banza power index of for each member of the department, and we are going to round the result to the nearest 100. Okay, so first, this is the solution. So let's have a solution here. Okay, solution. So the given, let's copy the given, 5, 4, 3, 2. Okay, and this is your voter A, B, C, and D, or this is the voter B sub 1, B sub 2, B sub 3, B sub 4. Okay, so first is, as I've said, let's compute the number of collisions and then get that collision. Okay, so see here, number of collisions possible collisions. Okay, sorry, collisions. This is 2 to the our n here. Our n is 4, so we have 2 to the 4 minus 1. 2 to the 4 is 16 minus 1. 2 times 2 times 2 times 2. Okay, so we have 15 collisions. Okay, 15 collisions. Okay, so now we are going to get the winning collisions, or the losing collisions at the same time, and then make a table for the winning collisions. Okay, how to create the possible number of collisions. There are 15. Okay, so first is you are going to form a collision where that collision consists of one voter. Okay, so first is one voter, this one B, C, and then we have D. Okay, and then after that this is one voter. Okay, let's say this one voter for each collision. No, not Q, coalition. Okay, then the second is two voters for each coalition. Sorry, I guess we have wrong spelling here. Coalitions. Okay, so two voters. So all you have to do, the technique here is this one. We have A, for example, B, C, D. Okay, paired AB, paired A to B, and then we have here AB, and then paired again AB, A to C. So we have AC. So this is a collision which is represented by this symbol. Okay, I know that you are familiar with this symbol. Braces, bracket, braces. Okay, this is braces. Okay, so a pair of brace, this one, in which this collision represent two voters. Okay, so partner, we have this one here, AD, and then after that partner AC, BC. Okay, BC, and then BD. Okay, BD. Okay, and then lastly we have this one, CD. Okay, this one here, I'm sorry, we have CD. Okay, that one. Okay, so two voters for each collision, and then we have three voters. Okay, three voters for each collision. Sorry again, wrong spelling. For each coalitions. Okay, so if you have three voters for each collision, this is what are you going to do. Okay, so meaning to say each what do you call this one, each collision has three voters. So first is partner A and B. Okay, partner A and B. Okay, and then this one here you put C here. Okay, this is it has three voters, and then A, B, and then go to D. Okay, at 1. Next is after that partner A and C. We have A and C here to D. Okay, A, C, D. Okay, and then finally after that partner this one here, I guess maybe there. Okay, this one BC. Okay, this one here BC partnered with D. Okay, BCD. Okay, so that's how you are going to form a collision that will consist of three voters. So what's the technique here? How would you know that there are four collisions if you have three voters in each collision? How would you know that for each collision there are 1, 2, 3, 4, 5, 6 collisions in which each collisions have two voters? Okay, the same is true for this one. How would you know that there are 4? How are you know that it will not repeat? Okay, so the secret here, which is cannot found in the cannot be found in the what they call this one, in the module, which you can hear in this discussion, this lecture video, is that the formula is can be found in your statistics. Okay, this formula here, combination of n taken r. Okay, combination of n objects taken r at a time. Okay, so this is what we call combinations. Okay, combinations, as you can see, we combine combinations of n objects taken r at a time. Okay, so that's what we mean by this symbol. And the formula is this one. This is very familiar: n factorial over r factorial times n minus r factorial. Okay, so that's the formula. So for example here, I am pretty sure that there are only 4 by using this formula. Okay, by this formula here. So let's try. Our n is 4. We have here our n is 4, and our r is this one. Okay, this is our r. Okay, let's have this color here. So this is our r, this one here. Taken 3 at a time. 4 objects, 4 taken 3 at a time. Okay, 4 objects taken 3 at a time. 4 objects taken 2 at a time. We have also here 4 objects taken 1 at a time. Okay, that's what we mean by this symbol here, combinations. Okay, and we left only 1 here, which is 4 objects taken 4 at a time. Okay, I'm going to write it here before going to use that formula. Okay, this one here, 4 voters for each coalitions. Okay, so this is our r, that one. Okay, sorry. So let's now compute. If I am correct, if there are only 4 coalitions here. Okay, so using the formula, so we have C 4 taken 3. Okay, so we have 4 factorial. Our n is 4 divided by 3 factorial, and we have n minus r. Our n is 4, our r is 3. So 4 minus 3 is 1. So we have 1 factorial here. So, and we know that the n factorial is denoted by this one, where n factorial is equal to n times n minus 1. Let's say 1 here times n minus 2 times dot up to 3 times 2 times 1. Okay, so that's how you are going to, so it is decreasing. Example, if n is equal to 5, you have 5, 4, 3, 2, 1. 5 times 4 times 3 times 2 times 1 until it becomes 1. Okay, so this is 4 factorial here. So this is how you are going to simplify this in your high school statistics. This is this is 4 times 3 factorial over 3 factorial times 1 factorial. Okay, cancel out. So 1 factorial is 1, so 4 over 1, so this is 4. So there are 4 collisions here. We are correct. Okay, we are not misled. Okay, so in here also there are 6 collisions. Okay, is there missing or missing collisions here? Let's try to compute. So we have C4 taking 2, since our r is 2. So we have 4 factorial divided by 2 factorial. 4 minus 2, we have 2 factorial. Okay, so 4 times 3 times 2 factorial over 2 factorial times 2 factorial. So cancel out. So So we have 4 times 3 is 12 divided by 2 to factor 2 times 1. So here we have 6. So I'm pretty sure that we are correct. 1, 2. So you can see here 1, 2, 3, 4, 5, 6. Let's try again this one. C. 4 taking 1. So we have 4 factorial. We have 1 factorial times 3 factorial. Okay. So again, if you compute this, this is 4 times 3 factorial here over 1 times 3 factorial. So cancel out. So this is 4. We are correct. Okay. How about for the last one? Okay. For the last one, let's try is this one. I know that there is only one. Okay. I don't know if you analyze. There is only one coalition consisting of 4 voters. Okay. But if you compute the combinations part, as you can see here, 4 taken 4. This is 4 factorial times 4 factorial. 4 minus 4 is 0 factorial. Okay, 0 factorial is 1. Okay, 0 factorial is 1. So this is cancelled out. So this is 1. Okay, so we are correct. So these are now the number of coalitions. Okay, it depends upon how many voters. Okay, so if n is 5, then there are so many coalitions that you will make. So what we will do next is add the votes. Okay, so let's try this. Maybe this color, maybe this black color here. Okay, for this one, the vote is, we have 5. Okay, this is 4. B is 4. Sum of the votes. Okay, okay, this is only 1, 3, and this is 2. Okay, for this one here, we have, so AB, the weight is 5 plus 4 is 9. AC is 8. Okay, and then AD is 5 plus 2 is 7. Okay, BC is 4 plus 3 is 7. BD is 4 plus 2 is 6, and CD is 3 plus 2 is 5. Okay, well, how about ABCD? So for this one here, we have all you have to do is to add 9 plus your C is 3, C is 12. Okay, as you can see here, we have AB is 9, so you add the weight of the voter C, which is 3, is 12. So AB is 9 plus B is, this is 11. Okay, this is 11. ACD, CD, where is CD? CD is 5. RA is 5, so we have here 10. Okay, so let's wait. This one here, BC, we have BC, where is BC? BC is 7 plus your D is 2, we have 9. Okay, 9 here. Okay, and last one, if you add them all, we have 5, 9, 10, 11, 12, 13, 14. 14. So this is 14 here. Okay, 14. That one. Okay, so now we are going to choose, it says here in the step, okay, list all the winning coalition. So all you have to do now is to get all the winning coalition. Okay, the winning coalition, it says here, is a set of voters the sum of whose votes is greater than or equal to the quota. So our quota here is 8. Okay, or 8. So which one is greater than or equal to 8? Okay, so we have 5, 4. This one is not. This is not a winning coalition. I think this one here. Okay, this one. That one. And also this one here. These are greater than. Okay, this is greater than the quota, greater than or equal to the quota. And also this one here, we have 14. Okay, there are how many? How many winning coalition? We have 1, 2, 3, 4, 5, 6, and 7. Okay, there are 7 winning coalition. So we have, let's make a table here. winning coalitions. Okay, coalitions. Okay, and then let's try to write the number of votes here. Okay, so I'm going to make a table, but don't worry, I am going to fast forward this point here. Okay, so that it will not add a time to the video. Okay. So we are done with making our table. So let's plug in now our winning coalitions A, B, and AC. We have here, let's try this color, A, B, and then AC, which is the value here is 9 and 8. I guess, am I right? 9, 8. And then ABC, ABD. ABC, 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 and then ABD. Okay, so ABC, ABD, we have 12, 11, 12, and then 11, and then ACD, okay, ACD, and then BCD, BCD here, which is 10 here and 9 also here. And then finally, the last one is that one, ABCD. Okay, we have ABCD. Okay, so that's how you are going to, and this is 14. Okay, so now we are ready now to calculate the second step. I guess the second step, am I correct? Okay, so where are you? List all the winning coalitions. So the second part is we are going to identify the critical voters. Okay, so meaning to say, if you a critical voter here, if you if the voter leaves the winning coalition, the coalition becomes a losing coalition. So that's what we mean by a critical voter. So let's continue to write it here. Let's try to write critical voter. Critical voter. Okay, voter or voters. Okay, so if I take out, so remember that, let me write it here. Let's have this color. Our A, B, C, D. Okay, this is, I guess, 5, 4, 3, 2, 1, 5, 4, 3, 2. Am I right? 5, 4, 3, 2. Let's go back again. We have 5, 4, 3, 2. Okay, I am correct. So let's look at here. If I take out A, so what would be the value? What would be the value of what is the total number of votes if I take out A? A is 5, 9 minus 5, and let me write it here, the quota. The quota is 8. Okay, if I take out, if this voter leaves the coalition, 9 minus 5 is 4. Okay, and 4 is clearly not greater than or equal to 8. So therefore, A here in this coalition, the first, okay, let's say this one here, the first coalition, let's say this color here, A is a critical voter. Okay, P also is a critical voter, because if this voter leaves the coalition, 9 minus 4 is 5. Okay, so critical voter. And A and C also is a critical, A and C. And then for this one here, if A leaves, we have B is, and C is 4, 4, 3 is 5 plus 5, 4 plus 3 is 7, okay, which is not greater than or equal to 8. So therefore A is a critical. And then if B leaves, B is 4, 12 minus 4 is 8. So therefore, B is not a critical voter. Okay? So this one here, B is not a critical. This one, no? This one here is not a critical voter. That one. C, if C, which is the weight of C is 3. We have 12 minus 3 is 9, which is greater than or equal to 8. So therefore, C also is not a critical voter. Okay, in this collision. Or this one here, A. So A, this one is a critical voter. B, D. B, 10. B is 4. 11 minus 4 is 7. So therefore, this is critical. Okay. D, D is 2. 11 minus 2 is 9. So therefore, D is not a critical voter. Okay. It's not a critical. A here is a critical. C, this is 10. C, 10 minus 3, the weight of C is 3, 7. So therefore, C is a critical voter. How about D? D is 2. 10 minus 2 is 8, which is greater than or equal to 8. So therefore, D is not a critical voter. How about here? B, C, D. If I take out B here, which is 4, so critical because 9 minus 4 is 5. So B is a critical voter. D, C here. C is 3. 9 minus 3 is 6. So we have here C also is a critical voter. D, 9 minus 2 is 7, which is also not greater than or equal to 8. So therefore, D is a critical voter. How about here, A, B, in this collision, in the last one? Okay, so we are done with this. The one, that one, this one here, that one, that one. So we live in the last row. If I take out A, which is 5, 14 minus 5 is 9, which is greater than, so therefore A is not a critical voter. Okay, B, 14 minus 4 is 10, B is not a critical voter. C, and so on. We have 11, D is 2, 14 minus 2 is 12. So therefore, the answer is none. Here, none. Okay, no critical voter. Okay, so we are done with step number 2 here. So now we are going to count. We are going to count how many times each voter is a critical voter. Okay, so each voter. So as you can see here, in the table, so how many times the voter A be a critical voter? So A here, 1, 2, 3, 4, 5. Okay, 5 number of times. Voter B is a critical voter. Okay, for B, 1, as you can see here, A is 1, 2, 3, 4, 5, B is 1, 2, 3. Okay, we have 3 here. C is 1, 2, 3, we have 3 also here, and then D is only 1. Am I right? 1. Okay, so now we are ready to get the power index. Step 4. So this one here, number of times voter V is a critical voter. This can be found in the steps. Okay, this one here, number of times voter V is a critical voter. Okay, divided by the number of times any voter is a critical voter. So what is the value here? Okay, number of times any voter is a critical voter. So all you have to do is to write it here. So the number of times any voter is a critical voter. Number of times any voter is a critical voter. Okay, the value here is All you have to do is to count them all here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the answer here is 12. Okay, that one. So the formula for the Banza Power Index, or BPI, okay, is this one here. Okay, let me put it somewhere here. This one. So for step 4, this one here, step 4, this one, the BPI, I'm going to write it here, the BPI, Banza Power Index, or not the Bank of the Philippine Islands, not that one, of any voter V is given by this formula. Okay, this one here, this is the formula. Okay, number of times voter V is a critical voter, and this one here is number of times any voter is a critical voter. Okay, so the V here is your voter V1, V2, V3, and V4, or the ABCD. Okay, if you denote the voter V1 as A. Okay, so let's try to compute now here. So we are now ready to compute the Banza Power Index. So therefore BPI, okay, BPI of voter A, so let's try to write it as A, not V1. It is okay if you use V1 here. So we have, the numerator is this one, the number of times voter V is a critical voter. So for A, we look at for A, we have 5 over 12. Okay, so let's get the, so I'm sorry, I have to get the calculator, just wait. As you can see here, okay, I'm back. So 5 divided by 12, and then convert to 2 decimal place, 0.42. Okay, 0.42. And then for the BPI of BPI of B is 3 over 12. The BPI, sorry again, so what happened to my hand, of C is again 3 over 12. So let's try to compute 3 divided by 12, and we have 0.25 here, 0.25, and here we have 0.25. And the last one for the BPI of D, we have 1 here, so we have 1 over 12. Okay, BPI of D is 1 over 12. Okay, so 1 divided by 12 is 0.08, that one. Okay, so as you can see, the sum of the, let me give you a remark here, or a note, the sum of the Banza Power Index is always equal to 1. Okay, or it maybe it depends upon on how you write in the decimal expansion. Sometimes it could be 0.99, but that's okay. But it is the sum of the Banza Power Index is always equal to 1. Okay, it should not be greater than 1. Okay, so that's how you are going to compute the Banza Power Index. So as you can see here in this example, which is more powerful? Okay, so as you can see, the most powerful is this one. Okay, the voter A. Okay, because his Banza Power Index is 0.42 or 42%. Here we have 25%, 25%, and here we have, it's only 8%. Okay, so that's what we mean by Banza Power Index. Okay, so I hope you are learning. This is our last topic. I'm sorry that I have to say goodbye. I want to discuss the other topic, but you know the time is very short, and we have to end this semester. Okay, so I'm glad that I am your teacher. I'm glad also that you are my student. And please don't forget, if you are not my subscriber yet, then all you have to do is to click that red button. Okay, red subscribe button and the bell button down below. There are so many videos that I'm going to make, not only this MMW, but maybe if you have time, you can visit my YouTube channel. You can watch the calculus part, and later I'm going to make a video about algebra and trigonometry, calculus 1, calculus 2, and many other subjects. Okay, solve problems, and so on, trivia problems, and so on and so forth. Okay, so thank you so much, guys, for watching. God bless everyone. I hope you will pass the exam. And I'm sorry, before I go, I'm sorry that I wasn't able to give you your scores, because there are students that wasn't able to take the exam yet. Okay, please be patient with me. Okay, so I will decide later if I'm going to close the Google form, and then I will not accept any student. But if it depends upon you and me, if ever you have mercy to your classmates, then maybe we will not close all those Google forms. Okay, thank you so much again for watching. God bless everyone.
Let go, you decide if you ever